Hello classmates! Today we will learn about the operation and maintenance of bare conductors in the context of outgoing feeder bay equipment. In this lesson, we need to master the basic overview of bare conductors and the operation and maintenance of different types of bare conductors. After learning, you should be capable of distinguishing between different categories of bare conductors and performing basic operation and maintenance tasks on them. At the same time, through this study, we aim to cultivate the craftsmanship spirit of inspection and maintenance personnel and the awareness of teamwork. The key point of this lesson is the basic overview of bare conductors, and the difficult point is the operation and maintenance of different types of bare conductors. Let's watch a video.
215 meters, 70 stories high. This is the height that Wang Jin, an ultra-high voltage live line maintenance worker, must climb. The rapid development of power grid construction has led to increasing heights of transmission towers and higher voltage levels that live line maintenance must face. The Yindong line, stretching from Lingwu, Ningxia in the west to Qingdao, Shandong in the east, is the world's first plus or minus 660 kilovolts ultra-high voltage direct current transmission line. This single line can support nearly 1/10 of Shandong province's electricity demand, so it cannot be powered down. Live line maintenance on plus or minus 660 kilovolts ultra-high voltage lines had no precedent in the world and no prior experience to follow. For this reason, Wang Jin and his colleagues conducted repeated tests, watching helplessly as dummies in shielding clothing were struck or burned by electric arcs. If it's taken down and you see the skin inside is scorched, this distance is not acceptable. On October 17, 2011, a pin drop fault occurred in the Shandong-Dezhou section of the Yindong line. Facing the plus or minus 660 kilovolts ultra-high voltage DC strong electric field for the first time, with life and death uncertain, Wang Jin decided to go himself. It really requires some courage. No matter how dangerous the job is, someone has to do it. Now we see the equipotential electrician has climbed onto the soft ladder. He has taken out the equipotential transfer rod. The entire process took only a few seconds. The 660 kilovolts voltage was conducted through the potential transfer rod into Wang Jin's shielding suit, integrating his entire body into the ultra-high voltage electric field. Wang Jin became the world's first person to perform live line maintenance on a plus or minus 660 kilovolts ultra-high voltage DC transmission line. In 2014, Wang Jin's name was listed among the winners of the second prize of the National Science and Technology Progress Award. When I go home at night and see the various lights illuminating the entire city, I feel a sense of accomplishment. For ordinary citizens, being able to use electricity normally and with peace of mind is the greatest trust they can place in us. My work is worthwhile.
Through the video, classmates saw Wang Jin, carrying the equivalent of 1,000,000 volts, performing maintenance on high-voltage overhead lines. While marveling at his fearless courage, we also better understand that the maintenance of conductors is extremely important for the power system. The craftsmanship spirit of maintenance personnel striving for excellence is also essential. Next, let's specifically learn the relevant knowledge about the operation and maintenance of bare conductors. Wires without an insulating sheath are called bare conductors. In power systems, bare conductors include hard conductors and soft conductors, mainly used for outdoor overhead lines. Among them, bare conductors that collect and distribute electrical energy within the system are called busbars. Bare conductors used for long-distance transmission of electrical energy outdoors are called overhead lines. The material, shape, and size of bare conductors are commonly represented by the following method. Material: copper is represented by the letter T, aluminum by L, steel by G. Hard material is represented by Y, soft material by R. Size: stranded wire is represented by J, cross-sectional area is indicated by numbers. Single wire diameter is represented by phi. For example, LG35 represents an aluminum stranded wire with a cross-section of 35 square millimeter. T4 represents a single-strand copper conductor with a diameter of 4 millimeters. Common types include round single wire, bare stranded wire, and iron wire. Round single wires are commonly made of copper or aluminum. Aluminum single wires include LY and LR types and are generally used as the core for power wires and cables. Copper single wires include TY and TR type. Bare stranded wire is a stranded wire formed by twisting multiple round single wires together. This type of conductor is relatively soft and has sufficient strength. The core wires of overhead power lines and cables mostly use stranded wire. The representation method for the number of strands and single strand diameter is to write the number of strands and the diameter together. For example, 7 by 2.11 indicates a stranding of 7 strands, each with a diameter of 2.11 millimeters. Iron wire is often used in low-power overhead lines, with galvanized iron wire being more widely used. After understanding the basic meaning of bare conductors, let's look at the operation and maintenance knowledge for busbars and overhead lines within bare conductors. In substations, the connections for distribution devices at various voltage levels, as well as the connections for electrical equipment like transformers and their corresponding distribution devices, mostly use bare conductors or stranded wires with rectangular or circular cross-sections. These are collectively called busbars. The function of busbars is to collect, distribute, and transmit electrical energy. Since busbars carry huge amounts of electrical energy during operation and withstand significant heating and electrodynamic force effects during short circuits, it is necessary to reasonably select the busbar material, cross-sectional shape, and area to meet the requirements for safe and economical operation. Busbars can be divided into hard busbars and soft busbars by structure. Hard busbars are further divided into rectangular busbars and tubular busbars. Rectangular busbars are generally used from the main transformer to the distribution room. Their advantages are convenient construction and installation, small changes during operation, and high current carrying capacity. But their cost is relatively high. Soft busbars are used outdoors where the space is large and some conductor swaying does not cause insufficient clearance between lines. Soft busbars are simple to construct and have low cost. Generally speaking, door installation of busbars requires meeting certain environmental requirements such as temperature and wind speed in practice. Under the condition that the above requirements are met, insulated busbars are generally maintenance-free. However, in cases of heavy pollution, if necessary, all exposed electrical endurance parts and sheds should be cleaned. During routine inspections, it is necessary to pay attention to whether there are any discharge sounds, corona, or other conditions affecting the normal operation of the insulated busbar during operation. At the same time, use an infrared thermometer to measure the surface temperature of the joints of each section of the insulated busbar and record the temperature changes. Under rated current, the surface temperature limit of the insulated busbar is about 65 degrees Celsius. During disassembly, replacement of parts, or after a long shutdown, perform insulation resistance and power frequency withstand voltage tests on the insulated busbar. If necessary, after a power outage, disassemble and inspect the insulating cylinder. 1 year after the busbar is put into operation or during main transformer maintenance, measure the insulation resistance of the insulated busbar at any time. During subsequent maintenance every 3 to 5 years, perform a power frequency withstand volt test on the insulated busbar. The withstand voltage value can be decreased gradually. Overhead power lines are the main channels and tools for transmitting and distributing electrical energy. The structure of overhead power lines mainly includes towers/poles and their foundations, overhead conductors, insulators, stay wires, crossarms, fittings, lightning protection facilities, and grounding devices. Inspections of overhead lines can generally be divided in regular inspections, night inspections, special inspections, fault inspections, tower/pole inspections, and supervisory inspections. Common faults in overhead power lines include conductor damage, broken strands, fracture, heating of conductor joints, discharge accidents between conductors and objects they cross over, single-phase grounding, two-phase short circuit, three-phase short circuit, and phase loss. To ensure the safe operation of the lines and prevent accidents, in addition to regular inspection and patrol of the lines, we must also pay attention to lightning protection, heat prevention, cold prevention, wind prevention, flood prevention, and contamination prevention. Classmates, in this lesson, we learned about the concept of bare conductors, representation methods, and the operation and maintenance of busbars and overhead lines. Combined with the above knowledge point, we learned the precautions for actual line maintenance. I hope that through this study, everyone can further improve their safety awareness during inspections, teamwork skills, and the consciousness of strictly adhering to operating regulations and procedures. Finally, please complete the following exercises. That's all for this lesson. Thank you, everyone.